Good afternoon, class. I want to hope that you are doing very well at home. Today's topic is heating effect of electric current. It's a topic that we are supposed to cover in Form 3, and it is good to note what the topic entails. And the topic entails producing heat because of electric current. So it's good to note these statements that when current flows in a conductor, electrical energy is always converted to other forms of energy. These forms of energy, we can have heat, we can also have light, we can have others. So electrical energy passing through a conductor, it generates heat always because of resistance. This is the most important term, because of resistance of the conductor. The conductor offers to the flow of current. So we have some devices that produce heat due to electrical resistance. The first one we will talk about electric bulb. So you can see the electric bulb that I have drawn. So it has a filament. When the current comes, there's high resistance at the filament, and this filament now produces the heat, and then we have the light. So that is for the bulb. We have another one, which is electric kettle. So I know you know this electric kettle, there's something inside. There's a coiled wire, and this coiled wire is the one that produces the heat, which heats the water that we put in that kettle. So this is the electric kettle. So this one is used at home, of course, to heat the water. So we have the production of heat. It's actually due to the the production of heat due to electric current is called heating effect of electric current. So we have the factors affecting electrical heating. We have number 1, amount of current. 2, the resistance of the coil. 3, it is the amount of time you subject the coil on the current. So let's look at each factor one by one. So the first one is the amount of current. So the amount of current, if you have more current, you shall have more heat produced. So when the experiments are done, the amount of heat produced is always directly proportional to the square of the electric current. So we'll have mathematical representation as this, where H is the heat and I is the current. The second factor is the resistance. So also the amount of heat produced is directly proportional to the resistance of the conductor. So we'll have heat is directly proportional to the resistance of the conductor. The third one is the time. The amount of heat produced is directly proportional to the time of heating. So we have heat is directly proportional to the time of heating. So when we are combining the three factors, we'll have heat is directly proportional to I squared RT. So we have combined them. So if you remove this proportionality sign, you say H is equals to K I squared RT. So taking H to be 1, I to be 1, R to be 1, and T to be 1, K will also be 1. So if you substitute 1 here, it will be H is equals to I squared RT. And since I know the formula, I is also V over R, I can substitute this one to have H is equals to, instead of I squared, I will have V over R squared RT. And finally, I will have the equation H is equals to V squared T over R. So this is another formula of calculating the amount of heat. So we have the two formula, which you have to note, this one and this one. So we have an example that we are going to look at. An iron box has a resistant coil of 30 ohms and takes a current of 10 amperes. Calculate the heat in kilojoules developed in 1 minute. So we have the resistance 30 ohms, current 10 amperes, time 1 minute. It is good to know that you have to convert this time to seconds. So that is 60 seconds. So I'll apply my formula H is equals to I squared RT. So I is 10 squared times resistance 30 times 60. So it's going to be 180,000 joules, and this is going to be the same as 180 kilojoules. That is the end of our lesson today. In our next lessons, we are going to look at more examples. Thank you. Have a nice afternoon.